The area of a sector of a circle is 54 pi and its arc length is 6 pi. Find the central angle of the sector. We want to find the measure of this central angle. And a central angle has its vertex on the center of the circle. The hint says use the formulas for the area of the sector and arc length and solve each equation for the angle. Then take the equation and solve for the radius of each circle. And the second hint says the formula for area of a sector is A equals pi radius squared times the angle divided by 360. And the formula for the arc length is arc length equals 2 pi radius times the angle divided by 360. So let's do exactly what it says. We're going to use the formula for the area of the sector first. A equals pi radius squared times the angle, the central angle, divided by 360. And we're going to solve this equation for the angle. So we're going to plug in 54 pi for the area. We're given that the area of that sector is 54 pi. We're going to divide both sides of this equation by pi radius squared because we want to isolate angle. And then we're going to multiply both sides of the equation by 360. We're left with 360 times, and the pi's cancel, times 54 over r squared equals the angle. So next we're going to use the formula for arc length and solve for the angle. So the formula for arc length is arc length equals 2 pi r times the angle over 360. And we're going to plug in 6 pi for the arc length. 6 pi equals 2 pi r angle over 360. So we're going to divide both sides of the equation by 2 pi r because again we want to isolate the angle, and we're going to multiply both sides of the equation by 360. So our 360s cancel on the right, as do our 2 pi r. And we're left just with angle on the right, and on the left notice our pi's cancel, and 6 and 2 reduces to be 3. So we're left with 360 times 3 over r equals the angle. So our next hint said, then take the equation and solve for the radius of each circle. So here's our equation. 360 times 3 over r equals angle. And this equation says 360 times 54 over r squared equals angle. So notice we have two equations both equal to the same thing. So we can substitute this value in for this angle value, and then we'll have an equation. So when we set those two equal to each other, we get 360 times 54 over r squared equals 360 times 3 over r. So let's clear our fractions, and we'll do that by multiplying both sides of the equation times r to the highest degree, which is a 2. So we're going to multiply both sides of this equation by r squared. And so we get r squared 360 times 54 over r squared equals r squared times 360 times 3 over r. So notice r squared cancels on the left, and we're left with 360 times 54 equals, and here r cancels and we're left with r on top. So equals 360 times 3 times r. So now we just solve for r. We're going to divide the right-hand side by 360 times 3, and then we're going to divide the left-hand side by the same thing to isolate the r on the right. So notice the 360 cancels, so we're left with 54 divided by 3, and that reduces to be 18. So the radius is 18. Notice we isolated the angle in this equation and in this equation, so we can use either of these two equations to find our angle. Let's use this one. 360 times 3 divided by 18, the radius, equals our angle. Use this. 18 divided by 3 is 6. 3 divided by 3 is 1. 6 goes into 6 one time. 6 goes into 360 60 times. So our angle equals 60 degrees.